In chemistry today, we will talk about the physical properties. Physical properties can be divided in two groups. The first one is called the qualitative properties of matter. The second one is what we call the quantitative properties of quantitative physical properties. So let's see what the differences are. We'll start with the first one, which is often the easiest one, which is what we call the qualitative data. Qualitative data is gathered by us through observations, and it is done with four of our five senses. We have our eyes, and through our eyes we can see colors. So for example, we can have a color here which is light gray, or we can have this brush which is black. We can also see if something has a luster. So for example, if you think of this brush right here, this end here is more of a matte color, whereas the edges is more of a shiny. This one here is a bit shiny, so it has more luster. So this is an example. So this is what we can gather for information through our eyes. The next one will be our nose. So through smell, we can see, is there any odor coming from what we are doing? Sometimes there's smell. You can smell, for example, if something is burning. We can also, with our hands, with touch, to figure out some information. We can see what kind of state it is. It is a solid or liquid or a gas. And with our eyes, we can still see that. We can see the difference between an ice cube and liquid water, and if it is vapor. We can also, with the texture, for example, with your finger, if you take this rod right here, it is very smooth. If you take, I have a good example here. If you take this sample here, we can see amethyst on, let's see if I can go this way so you can see it. I have amethyst on this side. So it is a rough texture. And on the other side, you have a granite, which is also a rough texture. So soft and rough is something that we can notice. Another one will be malleability. So for example, if you have a wrapper like this, and you take a wrapper and you are wrinkling it, you can still unwrinkle it. And there's some malleability that is right here. Something can bend, and we can also notice that. So here is an example. We have a cord and we can move it, and it is malleable. All of these type of characteristic, we can give them qualities. Quality. This idea of qualities is what makes those qualitative properties so important. Now, these are made by senses. What's interesting here is that everybody's eyes see things differently, smell things differently, touch and feel things differently, and can hear sounds differently. Oh, I didn't mention how we can notice sound. If you open a pop, let's see, a pop can with, let's say, a pop, you notice you can hear the bubbles coming out. That's an example. Good. So these can be done. The only sense that we cannot use in the lab is taste. You don't want to taste anything in a science lab, even though if you take the oldest chemical lab that we have on the planet has been the kitchen, where we can do chemical reaction for cooking, for bread, for sauces, for desserts, for creams, and so on. Lots of things we can do. However, in the lab, we cannot taste. All of these are important. They are individual. They are specific to the researcher, to the human. We can use adjectives for this. Now, when we are looking at quantitative data, that's here for this one, we can actually measure with tools, so we can have a very specific number and units associated with the property of matter. And that's what we're going to see. We're going to look into that in one moment. So give me a moment. I'm going to write the words here. Now, if we're looking at quantitative data, here we have a variety. We have viscosity, melting and boiling points. We have the solubility. We also have hardness. We have conductivity and density. Now, these are interesting because you can actually use units to characterize many of those. So for viscosity, for example, you can look at substance to see how long would it take to, let's say, go down a hill or like a ramp. You can say oil in a car. If you are to move the oil, how easily it can move and then can come down to the bottom of the oil pan in your car. What happens to the viscosity if, for example, oil in the machine is cold or hot? So here, for example, you could have centimeter per second. How does it flow? Something to look into. If you are looking for melting point and boiling point, so for example, if you have an ice cube that is becoming water, this is called a melting point. And we know in chemistry that this happens at 100 degrees for water. Actually, it happens at 0 degrees for water. If you have here water and the water becomes vapor, what will happen here is we have a boiling point, and this is happening at 100 degrees Celsius. And how do we measure temperature? We can use temperature using thermometers. So this one is an example of a thermometer that I use in the kitchen. So it's a bit blurry. So here, just to see how well something is cooked. Thermometers allows us to give melting points and boiling points. These are specific information in degrees Celsius, for example. So if you have different humans given similar environment, similar conditions, similar materials, we would have similar outcome. So that's something to look into. Keeping in mind that depending where you are around the world, some of you might work with Fahrenheit, and some of you may use Kelvin if you're doing some research. So these are examples of units to give a characteristic of what quantitative physical properties. Another one will be the solubility. So an example for solubility would be gram per liter, for example. So here, if you have vinegar in water, here it is a 5%. 5%. Let's see, it is acetic acid in water. So here you have grams of a substance per liter or percentage per liter. So here the solution, the solubility of something that we dissolve in water is something specific. So all of the bottles from the same companies, and if they have 5% solubility, makes it a difference. Perfect. The hardness. Now, if you think of copper is a great thing because it's quite sturdy. We can use it for roofing, and it protects the home. However, we can also think of it's not as hard if it is it's a bit thinner, or if you're using a fine point. You can mark this. You can mark aluminum, but you will not be able to mark, for example, titanium, which is a much harder materials. If you're in geology and you love mineralogy, we also have the Mohs scale, and it's a scale from 0 to 10, where 1 is the hardness of talc and 10 is the hardness of diamond. So what happens here is that we can use a hardness that is specific, so different scientists around the world would have similar results. The next one is about conductivity. So if you think of, we have here our cord made of copper. You want things to be able to conduct electricity. And interestingly enough, we can actually measure how a wire works. Using a multimeter, we can figure out how much current is going through the wire, what is the resistance of a component or a type of metals. That's important because once you know your characteristic of your, when you know the physical properties of your matter, that's how you can actually have to mainstream your constructions, mainstream your wires to make sure that it's safe for everybody. The next one is about density. So density, we have this small experiment I had earlier. We have here a tube where we have ethanol. You have here, we have ethanol, which is lighter than water. So ethanol is in blue, water is green, and we have here little particles that are heavier or denser than ethanol, but not as dense as water. And at the bottom here, you have these little particles of white plastic at the bottom. So here you have a variety of density. If you shake it, what will happen? They will take their respective place with here what's heavier at the bottom, what's lighter at the top, and you can see that slowly what was mixed will find its own place, because when you have two substances that are insoluble, they don't mix well together and they will find their own spots, and here using density. And these are examples of what's the difference between quantitative physical properties and qualitative physical properties. So for this one here, for quantitative, we have a word that's called quantities. Quantities and units. So when you talk about quantities, you have units such as centimeters, time in second, temperature, you have mass here. For density, we have grams per centimeter cube. You have even a ton per meter cube. Conductivity could be in amps like this, could be the resistance in ohms. So this idea here is that you have units that can be measured by tools. That's important because when you can in science reproduce the results of another person, that's how we can advance science. But also if you have a company creating goods, you want to make sure that there's uniformity in what you create so that it's safe for everybody and everybody know what they get.